sorry, if you're interested in getting it, it is available on Amazon. So we're going to start with Chapter 7, Expressions. Now, before I start this, I just kind of want to give a few reminders to people to remember, check the description of this video to see any updates that I might add as time progresses. And then also make sure that you attempt the problems on your own first before coming and watching this for explanations. Now, let's review a couple of things that you have to remember for expressions. So for the expression stuff, you want to remember PEMDAS. So remember, PEMDAS is parentheses, exponents, multiplication, division from left to right, and then addition and subtraction from left to right is the order that you're supposed to be doing your math in and simplifying things in. Now, another thing to remember is, hold on, I have a little note here of what I wanted to say. Oh, the equivalent expressions trick. So whenever you're trying to find equivalent expressions, like with number 1, if you have no idea what you're doing, you have no idea how to simplify this, there's a trick that you can use to still get this correct, and I'm going to show it to you now. It's not the most efficient way to solve, but it will help you get it right if you just forgot algebra for some reason, or you're just confused and want to just make sure that you get this right and check whatever answer you got. So what I say is use the number 2. That's usually one that works to eliminate the most answer choices, and plug it into the question and then plug it into the answer choices. If you get the same value, they're equivalent expressions. They're equal, because if they're truly equal, if you do the same thing to each of them, you should get the same number. So we're going to plug in 2 for x over here. So then that's going to be 6 to the 4th times, and we're going to plug in 2 for x right here. 4 times 2 is 8. So then that's going to be 8 to the 3rd power. And so 6 to the 4th power, oops, where is my calculator? So 6 to the 4th power, 6 times 6 times 6 times 6 is going to be 1,296. And then if we do 8 to the 3rd power, that's going to be 512. Now, again, this is not the most efficient way. I'm just giving you an example of how you would know that you have the right answer. So you could plug that in, see what value you get. So we're going to do 512 times 1,296. And that's going to give us 663,552. And then you would do the same thing by plugging in 2 for each of the x's and see which one gives me that value. So let's go ahead and do that. So right away, let's just see, okay, it's not going to be one of these probably, that's too little for 2 times all of that. I'm going to start with like the bigger numbers because we have such a big value down here. So I'm going to say 5,184 times, and then remember we plugged in 2, so it's going to be 2 to the 12th power. So if we do 2 to the, hold on, I hate this calculator, 2 to the 12th power, okay, that's going to be, and then times 5,184, that's equal to what is that, 21,233, so definitely not equal. You get like 21 million something, so it's not that one, and you can cross that out. Now let's do this one. So we're going to do 5,184, and that's going to be 2 to the 7th power. So 2 to the 7th power is equal to 128, so then we do 128 times 5,184. And that gives us the same exact value up here of 663,552 when we plugged in 2, so that is the correct answer. So that's what you can do as like a workaround method if you just forgot your power rules for some reason on test day and still get it right. Now, the efficient way to do this problem is to do your power to a power rule, and you could say, okay, this is 3 to the 1st power technically, this is x to the 1st power, I have to use my power to a power rule for each of these, which says that if I have a power to a power, I multiply the powers and keep the base. So 3, and then to the 1 times 4 is 4, 3 to the 4th, and then we have x to the 1 times 4 is just x to the 4th, and then that's going to be multiplied by this part right here. And again, we have 4 to the 1st power and x to the 1st power. So we're using power to a power for each of those. So it's going to be 4 to the 3, because 1 times 3 is 3. And x to the 3rd, because 1 times 3 is 3 again. So then you would just multiply, or do the exponents and then multiply these together. So 3 to the 4th power, that's going to be 81. So we have 81x to the fourth times, and then 4 to the third power is 64. So then it's going to be 64x cubed. So you have 81 times 64, which is going to be 5,184. And then you have the x's, they have like bases, x and x. So we can use our power rule, not our power rule, one of our power rules called product rule, where we are multiplying between like bases, then we add the powers. So we would add 4 and 3 and get x to the 7th power. So that's like the more efficient way to do it. And if you want to see this later, don't worry, it gets posted on YouTube if you're coming in a little bit later. For the person that just asked in the comments, it's going to be uploaded on YouTube. Okay, so let's go to the next one. Number 2, which of the following is equivalent to the expression right here? So really quick, whenever I see a number pressed up against parentheses, automatically on the test day, I think I should be doing distributive property. That's kind of like a little trick if you struggle to like figure out where to get started. So distributive property says that I'm going to multiply this -3 times each term inside of my parentheses here, and I would do the same thing for the 5. And then I just copy over the 2a while I'm doing that. So -3 times 4b is going to be -12b. And then -3 times -7a is going to be positive 21a, so plus 21a. And then now I'm going to distribute the 5 to each of these terms. So plus 5 times 2a is going to be 10a. 5 times 4b is going to be 20b, so plus 20b. And now I'm going to combine my like terms. So my like terms, let's start with the a's. So 2a plus 21a is 23a. 23a plus 10a is going to be 33a. And now let's look at the b like terms. So -12b plus 20b is going to be positive 8b, so plus 8b. So it's going to be f right over there. Give me 1 second to just grab some water. I forgot to do that earlier. And pour it. Okay, so let's go to this next one over here. So which of the following is equal to the expression, this all up there? So remember, PEMDAS. So let's go through PEMDAS. We have to simplify anything in parentheses. Well, there's nothing to simplify there. It's not like we have 1 minus 4 or anything. It's just a number, -4. So we don't need to do that. Next would be exponents. So I'm going to do the exponent part, which says -4 to the 2nd power. Now, -4 to the 2nd power, when it's written like this, is -4 times -4, which is positive 16. So we're going to copy down everything else, and we're going to say that this turns into positive 16. I'm going to just put it in parentheses just because that's how I like to write it. You don't have to. And then now we just did exponents, so now we go to the multiplication and division step, which you multiply and divide from left to right in that order. We don't have that issue where there's like multiple things, so we're just going to do the top. We see that there's division, so we're going to do negative 9 divided by 3, or you can think of it as -9 divided by 3, however you prefer. So that's going to be 2 minus 3 over, and then this is just -16. And now we're going to do our subtraction on top. So it's going to be 2 minus 3, which is going to be -1 over -16. And that's just going to cancel out. Negative over negative cancels out to a positive. So it's just C. So let's go to number 4. Which of the following is equal to the expression right here? So again, PEMDAS. So let's start with anything in parentheses. There's nothing here that we have to simplify, so we're good on that. Now let's go to exponents. So exponents would be right here. So we have -3 cubed. So that's saying -3 times -3 times -3, which is going to be -27. And then we copy over everything else. Now we're going to do multiplication division from left to right if we have any. So we do have division right here. We have the -6 divided by 3. So this is going to be 2 plus -2. And then minus a minus is a plus, so I'm just going to go ahead and make that plus 27. And now I'm going to do any addition from left to right. So 2 plus negative 2 just cancels out to 0. And then plus 27, that's just 27. So it should be K. This is practice for the ACT math section for anyone that's interested. Also, check out my series. I believe I linked it in the comments or wherever it says series on the thing. I can't see it from your perspective. But I just released a cramming guide for the SAT and ACT that's just $1.99. That comes with not just like the cramming guide, like I tell you how to find it, but also like videos of me explaining the formulas and things that you should watch out for test day if you need to cram, because I know the SAT is this weekend. So let's go to number 5. So it says that if n is not equal to 0, then all of this is equivalent to... So we have just two fractions. Just because there's a variable doesn't mean it's not a fraction anymore. It's still a fraction, so we still need to follow the rules for adding and subtracting fractions, which says that we need a common denominator. So I see that if I multiply by 3 here, I can get 3n. If I multiply by n here, I can also get 3n. That'll give me a common denominator. But I can't just do that to the bottom without changing the top the same way. So I have to multiply by 3 on top over here, just like I do on the bottom, and multiply by n on top here, just like I did on the bottom. So then I'm going to get 6 over 3n plus n over 3n. So now, when we're at this step, we keep the common denominator and we add the numerator. 6 plus n over 3n would be our answer, so it would be B. And let's keep going to number 6. Which of the following is equivalent to the expression right here? Now, whenever you have two terms plus or minus in parentheses, like we have here, there's two things plus or minus, two things plus or minus, that indicates that you have to FOIL. So FOIL is an acronym that stands for what you're multiplying in this situation. So the F stands for the first things that we're multiplying. So we're multiplying 9b times 4b. So 9b times 4b is going to be 36b squared. The O stands for multiplying the outer things, so C times 9b. So that's going to be plus 9bc. The I stands for multiplying the inner things, so negative 4c times 4b. So that's going to be negative 16bc. And then the L stands for multiplying the last things. Ooh, I don't like that that was not correct. Okay. And then the L stands for multiplying the last things, negative 4c times c, and that's going to be negative 4c squared. So now we just have to combine our like terms after we FOIL that out. So 9bc minus 16bc is going to be negative 7bc. So we're looking for negative 7bc in the middle, so it can only be G or H. And then the one that matches the rest of the problem would be H, because that's 36b squared minus 7bc minus 4c squared. Okay. Is there a way to get a hold of this workbook? Yes, it is available on Amazon. It's called Overcoming ACT Math by Sofia Garcia. And if you need a cramming guide, that's also part of my series. If you want to check it out here on TikTok, it's $1.99. And then let's go to, no problem guys, let's go to number 7. And for people saying slow down, I always get that a lot of people like the pace, a lot of people don't of these. But what I do is I upload these on YouTube later for anyone that needed me to go slower on a problem, because you can slow down my voice in the video on YouTube. So let's go to number 7. Which of the following is equivalent to the expression right over here? So again, we have to think PEMDAS. Whoops. Yeah, I'll show the cover again. It's Overcoming ACT Math by Sofia Garcia. It's also linked on my profile, like if you go to my home page on my website. So then now what we're going to do is parentheses first. So that means we have to do this part. And there's no calculus versions right now, no. So then it would be 7 minus 2 to the 4th plus 5, and then times 5, because negative 1 plus 6 is 5. Now we just did the parentheses part, so now we have to move on to exponents. So the exponents are going to be this guy right here and this guy right here. So it's going to be 7, and when you have a minus outside like this, this is saying you're subtracting whatever 2 to the 4th is. So we have to subtract 2 to the 4th. Well, 2 to the 4th is going to be 16, and then we need to add on whatever 5 times this is 5 squared. 5 squared is 25, so 5 times 25. We just did our exponents part. Now we have to do multiplication and division from left to right. Well, there's only this for multiplication and division. So we would do 5 times 25, which is 125. So So now you have 7 minus 16 plus 125. So we've done multiplication and any multiplication division. Now we do addition and subtraction from left to right. So we would do 7 minus 16, which is negative 9. And then we have negative 9 plus 125, which is going to be 116b. So now we're going to go to number 8. It says, which of the following is equivalent to this expression right here? So we're going to use power to a power rule right here. So remember, this is technically 2 to the first power and x to the first power. So if we're doing power to a power rule, we have to multiply the exponents. So 2 to the 1 times 2 is just 2. And then x to the 1 times 2, which is just x squared, basically. And then we would say plus x squared over x squared. So 2 squared is just 4, so this is really saying 4x squared plus x squared over x squared. So that's going to be 5x squared over x squared. The x squareds cancel out, and you just have 5. J is the correct answer. So now let's go to number 9. So for number 9, it says, which of the following is equivalent to the expression right over here? So power to a power rule says that this turns into x to the 4th. X to the 4th times x is going to be x to the 5th. And then I'm going to copy down this part right here. And I see I have minus x times x times x, so that's going to be minus x cubed. And I'm copying over the minus 2. And now I'm just going to copy down everything else on the bottom over here. Now, whenever you have expressions and you see that there's 4 things grouped together like this, it should be a pretty strong indicator that you probably have to do a grouping, like factoring by grouping. And what that is you group the parts of the expression. So like I group this part right here, and I take out the GCF. So right here, I'm going to take out x squared. Actually, I'm going to move it over here. So I'm going to take out x squared because that's a GCF there. And if I take out an x squared, I'm left with x cubed right there. And then I'm left with plus 2 right there. And then you go and you group this portion right here and factor it. But the whole point of you trying to factor right now with group factoring is to get the same thing in parentheses with the way that you're factoring this. So I want to get something times x cubed plus 2. So I have to think, how can I turn minus x cubed minus 2 into something times x cubed plus 2? Well, I could just multiply it by negative 1. So you see, I've achieved my goal of I have the same thing in parentheses that each of these is being multiplied by. And that's going to all be over. Now I'm going to group factor this portion down here. So these are going to be a group. So I'm going to take out an x and be left with x cubed plus 2. And these are going to be a group. And that would just be, remember, we want to have the same thing in parentheses. So x cubed plus 2. And I'm just going to multiply by plus 1 to keep it as x cubed plus 2. So the reason we're trying to get the same thing in parentheses is, and actually I'm going to move it all the way down here, is because once we have that, we can factor out the x cubed plus 2, and then in our other set of parentheses next to it, x squared minus 1 becomes another factor. And you do the same thing on bottom. You say, I'm going to group the x cubed plus 2 over here, and then x plus 1 becomes the other factor. So now I see I can cancel out this and this because they're the same thing. So now I have x squared minus 1 over x plus 1. So x squared minus 1 is the same thing as x plus 1 times x minus 1. And then that's all still over x plus 1. I can cancel out the x plus 1s, and I'm just left with x minus 1, A. So now let's go to number 10. Which of the following is equivalent to this expression? Again, we have to think of PEMDAS. So parentheses first. So we're going to say 2 minus 3 is negative 1. And then I'm just going to copy down everything else for you so you can see it step by step. So now we're going to do exponents because we just did parentheses. So E is for exponents. So I have to do the 5 squared. That's going to be 25 plus 3 squared is 9. I'm going to copy over the minus 1. All of that over negative 1 cubed is negative 1. So now I did my exponents. There's no multiplication or division on the top and the bottom. And then for addition and subtraction, I'm just going to go from left to right on top. So I'm going to say 25 plus 9, which is going to be 34. 34 minus 1 is 33. So I have 33 over negative 1. So then it's going to be negative 33. F. Good job for everyone that said negative 33. So give me a second to just grab water. Remember, if you're interested in getting this book, it's linked in my profile on my website. And I also have a cramming guide for the SAT and ACT for $1.99 and like in a TikTok series that I describe if you need that for your upcoming exam this week if you're taking the SAT. So then number 11, which of the following is equivalent to the expression right over here? So let's see, we're going to do power to a power rule over here. You can also think about it as like negative 3x times negative 3x. Some people might find that easier. So I'm going to say minus, and then negative 3x times negative 3x is going to be positive 9x squared minus x squared plus x, and then this is going to be plus negative 2 cubed is just negative 2 times negative 2 times negative 2, that's negative 8. So now what we're going to do is I'm going to say, okay, this is just minus 9x squared, negative 9x squared. And then I'm going to copy down the rest. And I know plus a negative number is just subtraction, so minus 8. And then I'm going to say, okay, I'm going to combine my like terms. Minus 9x squared minus x squared is going to be negative 10x squared plus x minus 8. So that's going to be E for that one. So let's go to number 12. Number 12 says, which of the following is equivalent to the expression right over here? Round your answer to the nearest whole number. Okay, so we have, again, PEMDAS. So parentheses first, so we're going to do 8 minus 3 first. That's going to be 5. So then I have 8 plus 5 squared over 3 squared minus 2 squared plus 6. So I just did my parentheses. Now I have to do my exponents. So I'm going to copy over the 8, and then I'm going to do 5 squared, which is 25, 3 squared, which is 9, and I'm going to subtract whatever 2 squared is, which is 4, and copy over the 6 right over here. And so I just did my exponents. There's no multiplication or division on top or bottom. So then I have to move on to addition and subtraction from left to right. So I have 8 plus 25 is going to be 33 over 9 minus 4 is 5. 5 plus 6 is 11. So then 33 divided by 11 is just 3. So it's going to be H. So now let's go to number 13. So for this one, you just have to distribute what's on the outside, the 2xy, to each of the terms inside of the parentheses. So 2xy, are these the type, really quick, I'm sorry, I've been ignoring the questions, I just realized. Are these all kinds of questions we'll see on the ACT? These are not going to be like the entire ACT math section. It's not going to be entirely like this because this is just one chapter on one concept. But yes, you will see questions like this on the exam. So let's keep going. So we're going to distribute this to each of the terms in the parentheses. So it's going to be 2xy times 3x squared. So that's going to be 6x cubed y. And then I'm going to do the same thing where I'm going to distribute 2xy to negative xy. So it's going to be negative 2x squared y squared. So that's going to be A. So let's go to number 14. So for number 14, it says which of the following is equivalent to the expression above. So I'm going to say I have negative 2 times, remember when I have 2 terms plus or minus in parentheses times 2 terms plus or minus in parentheses, that means I have to FOIL, which is an acronym that stands for what I multiply with this stuff in parentheses. F stands for first, so I multiply the first things, 5x times 3x. So that's going to be 15x squared. O stands for outer, so I'm going to multiply 5x times negative 2. That's going to be negative 10x. I stands for inner, so I'm going to do 2 times 3x, which is going to be plus 6x. L stands for last, so 2 times negative 2 is negative 4. Now I'm going to combine these like terms here. Negative 10x plus 6x is going to be negative 4x. So now I have negative 2 times 15x squared minus 4x minus 4. So then now I'm going to distribute negative 2 to each of these terms right over here. So negative 2 times 15x squared is going to be negative 30x squared. Negative 2 times negative 4x is going to be positive 8x. Negative 2 times negative 4 is going to be positive 8. So it's going to be negative 30x squared plus 8x plus 8c. Okay, so now let's look at number 15. So number 15 says we have all of this, and then if you look at the answer choices, it looks like they're factoring. So what we're going to do is we're going to say, okay, is there a greatest common factor we can take out over here? So you can use the answer choices to your advantage, and you could say, okay, it looks like for the number part, it has to be either 324 or 162 is the greatest common factor. Now, if you try dividing all of these by 324, you'll see that 810, it doesn't divide evenly. It's like 2.5. So it's not going to be 324 that we take out as a greatest common factor. So that means it has to be 162. 162 does go evenly into each of these numbers, so that's what we're going to take out as our greatest common factor for the number part. Now, we have to think, what's the greatest common factor for the x parts? So between x to the 9th, x to the 3rd, and x to the 7th, the greatest common factor would be x to the 3rd. Now do the same thing for the y's. Between y to the 6th, y to the 5th, and y to the 3rd, the greatest common factor is y to the 3rd. Now look at the z's. Between z to the 3rd, z to the 2nd, z to the 9th, z to the 2nd is the greatest common factor. So now that's the GCF that you've taken out, and you have to say, okay, well, if I take that out, what's left on the inside? So if I take this out, if I factor out all of this for my first term right here, I'm going to get, let's see, that would be, hold on, let me think for a second. That would be, is that 2 times? Yeah, that's 2 times. 2 times, and then that would be x to the, let's see, x to the 6th power, because x to the 6th times x to the 3rd gets you back to x to the 9th. Or you can think about it as like canceling out in division, whichever works for you. And then we're going to say, okay, what about the y's that were right there? So y, I'm trying to get back to y to the 6th if I were to multiply these. So it would be y to the 3rd right over there. And then now I'm going to say, okay, what about for the z's? So for the z's, it would be z, just regular z, because z to the 1st power times z to the 2nd power gets you back to z to the 3rd power. So right now, what I could do, because this is multiple choices, I could see, hey, is there anything here that that just matches the first part? And I don't even have to continue working on it if I don't want to. So I see that we have 162 x to the 3rd, y to the 3rd, z to the 2nd power for c and d. So now I'm going to keep comparing them. So then it goes 2x to the 6th is what we're looking for, y to the 3rd times z. And then, so if you look at the options, they're missing a z over here, so it can't be c, it would have to be d. She couldn't even do 162 times 2. I slept 2 hours last night, and I have ADHD. Leave me alone. If you don't want to be here, go somewhere else. And I'm still doing the live, because I promised everybody. So then let's go to number 16. The expression 2x squared minus 22x plus 56 is equivalent to. So let's go and do, I call this reverse foiling, like people call it factoring. But the reason I call it reverse foiling is because if you look at the answer choices, whatever's correct, you can just foil out and you should get back to this original thing. So it's kind of like you're doing the reverse of foiling in a way. So anyway, what you want to do is you want to ask yourself, okay, what 2 things multiply to give me this? So think of what 2 things multiply when I FOIL them, what gets me to this? So to get 2x squared, I would have to have 2x here and x here. That's the only way I could get 2x squared. So automatically just from that, I could see it's not A, B, or C. Then I have to decide, okay, what 2 numbers go here so that when I multiply and them, I get 56, but also when I finish foiling everything out and I combine my like terms in the middle, I get negative 22. So these both are positive 56, negative 8 times negative 7, 8 times 7. Thank you for the roses. And then what we see is that they both have a positive 56, so we just kind of have to test them out. Guess and check is usually the best scenario for people. Or you can see that these have to be negative numbers, like you get a negative 14x, negative 8x, so that's the only way to get a negative middle term, is if both of these were negative, like you can't just have two positives in that way and get a negative number in the middle. So I'm going to show you how most people would end up doing this if you can't like really see that in your head. What you would do is you would start foiling out D to see if it's the correct answer. So FOIL it out by saying F is the first things we multiply, so 2x times x, so it's 2x squared. O is outer, so 2x times negative 7 is negative 14x. I is inner, negative 8 times x, negative 8x. And then last is negative 8 times negative 7, so that's going to be positive 56. So then you see, okay, I'm going to combine my like terms here. So I have 2x squared minus 22x plus 56, and that's why I like to call it reverse foiling, because you get back to what you initially had and you know that you factored it out correctly. So it would be D. Thank you for the roses, guys. And then let's go to number 17. The expression 6x squared y is equivalent to which of the following expressions? So let's start with this one. Let's go and say, okay, 72 divided by 12, that's going to be 6. And then x squared is just going to stay there because there's nothing on the bottom to cancel out with or divide with. Now we have y squared over y, which is just based on the quotient rule, meaning we have to subtract our powers. It's just going to be y, because y to the second, this is technically y to the first, 2 minus 1 is just 1. So this is equal to 6x squared y. Now let's go to this one right here. So the 6x squared part we keep, but we're going to use quotient rule with y squared over y. You could think of it as quotient rule, or you could think about it as factoring, or not factoring, canceling out on top and bottom. Like you could think y squared is the same thing as y times y, so then one cancels out on top and one on bottom if you prefer that method. That's another way to think about it, but either way you're going to still get 6x squared times y. And then we're going to say 72 divided by 12, that's 6 again, so 6x squared y. This is also equivalent to 6x squared y. So then we're going to say that it's all three of them, so it has to be E. And thank you guys for all the likes and shares and everything. If anyone is interested in getting a cramming guide for the SAT or ACT exam, check out my series. I have a TikTok series that I just released, like literally today. It's an hour and 15 minutes of stuff you need to do to cram for the exam. And I'm actually releasing a bunch of other series throughout this week for other stuff that goes more in depth into like the English stuff, the grammar stuff, the English and grammar stuff, and like the reading stuff and math stuff as well. So, and it's only $1.99 for the cramming guide. The other stuff is like $4.99, but it's like going to be a whole course and everything that has all the videos and everything and tells you how to find like free practice and stuff like that. So let's go to number 18. The simplest form of the expression this is, so let's see. We're going to see, is there a common factor, a greatest common factor between 120, 105, and 15? So let's see. I think 15 goes into, does 15 go into each of those? Yeah, I think it does. So let's see. 15, I think, goes into 120 and 105, but I'm not positive about the 105. Yes, it does. Okay. So we have, if we divide each of these by the greatest common factor of 15, we're going to get an 8 on top for this portion, because 120 divided by 15 is 8. So it should be 8. I'm running out of room. Where should I put it? Okay. 8. And then if we are doing the 105 divided by 15, that's just going to be 7. And now we have to think about the x's right over here. So if we want to think about the x's, what's the greatest common factor we could take out on top? We could take out, let's see, that could be, you know what, actually, hold on. I'm thinking of like the best way to explain this. I feel like people wouldn't like my method. I feel like they like it a different way. I feel like people would like it if you do the greatest common factor on top first and then cancel out between that. I feel like that would be easier for most people to see, so I'm going to do it that way. So I'm going to say that I'm going to take out a 15 on top, and then I'm going to take out an x on top for the greatest common factors. I'm just looking at greatest common factors on top. And then between the y's, I'm going to take out the y as the greatest common factor, because between y cubed and y would be the greatest common factor. And then between z squared and z cubed, z squared would be the greatest common factor. So then, looking at just the top, I can think about, okay, if I took out 15xyz squared, what's left for the 120 portion right here? Well, there would be an 8, and then there would be nothing for the x because we took that out, and then y squared, because y times y squared, you can check it, y times y squared gives you y cubed, and then there's nothing for z because we took out the z squared, and then it would be plus, so now if we took out a 15, we divided out a 15, that means there should be a 7 there, because 105 divided by 15 is 7. And then we took out an x, so there should still just be one x over here. And for the y, we took out the y already, so there's nothing for that. And then for the z's, there should be a z here so that we get z cubed if we were to multiply this out. And then that's going to be all over 15x cubed yz to the 6th power. So, sorry, the comments are funny. So then we have 15 and 15 that can cancel out on the top and the bottom. And we can think that x would cancel out with x cubed, like with one of the x's in x cubed. So then we're just left with x squared. You could also use quotient rule if you prefer that, but I find that most students like this method better. So that's why I'm doing it this way. And then it can cancel out the y and the y on top and bottom. And then we have z squared, we could cancel out over here, and that would leave z to the 4th down here, because z times z, 2 of those z's cancel out with 2 of the z's over here. So this would be just z to the 4th. Sorry, this is getting a little bit messy because it's like rounded right here. So that would be, okay, all of that canceled out on top. We just have 8y squared plus 7xz over, and then this is going to be x squared z to the 4th. And then what we're going to do, the writing over everything messed me up. Oh, sorry. Yeah, I'll try to do this like another day on like separately. Like maybe I'll upload a TikTok on this problem and I'll make a note of it because like that did get a little messy. I can see how that would be annoying. So let's see. That would be D. So let's go to number 19. The expression right here is equivalent to, so again, the reverse foiling thing. You could just start foiling all of these out if you want to, but that's really time consuming. I wouldn't suggest that. So, but if you're bad at factoring, you could. So think about what two terms are going to multiply to give you 6x squared. Well, let's think. Oh, and also we could say what's a greatest common factor to take out. Let's see, is there a greatest common factor? Yes, there's a greatest common factor of 3 that we could take out. So we could say we're going to take out a 3 at first, and then we're going to be left with 2x squared minus 5xy plus, because all I'm doing is dividing by 3 because I'm factoring out a 3, plus, and that's going to be 3y squared. So now I could just copy over that 3, and now I have smaller numbers to work with, so it's going to be easier probably to factor these. So I'm just going to factor the part inside the parentheses right here. So 2x times x gives me 2x squared. And then I want to think, okay, when I FOIL this part out, I need to get back to what's in the parentheses right here. I need to get back to 2x squared minus 5x plus 3y squared. So I have to think, what two numbers can I put here so that when I FOIL everything out, I get back to this stuff in the parentheses. So what two things could multiply to 3y squared, and when I FOIL them out, give me this term in the middle? So let's think. That would just have to be 3y times y. So let's see. That would be 3y and then y. And then let's think, okay, if we have... it could be minus a minus or plus a plus to get to plus, but you have to have a minus in the middle. So these would have to both be minus, and you could check it. You just have to kind of like see this, the foiling stuff, like you just have to do a ton of the problems and get really good at it, or get really fast at foiling out the answer choices if you're bad at factoring it and seeing that and seeing which one matches the initial problem. But that's the great thing about these problems. There's so many ways to do it. So then what you can do now is say, okay, when I FOIL this out, 2x times x is 2x squared. And then if I do minus y times 2x, it's going to be minus 2xy. Minus 3y times minus 3y times x is going to be minus 3xy. Minus 3y times minus 3y is going to be positive 3y squared. And you'll see the middle terms, they get you back to the negative 5x squared, negative 5xy. So you did FOIL this out correctly. So you can say that this is the final factored version of this expression. So that would just be, let's see, that's just the k, letter k. Okay, so I remember why I used to cry now. Yeah, people hate foiling usually. Sorry, getting water. But let's go to the next one right here. Number 20, which of the following is equivalent to the expression, or sorry, I didn't mean foiling, I mean factoring. Foiling is easier, yes, you're correct. So then let's go to number 20. Which of the following is equivalent to the expression right over here? So again, you could FOIL all these out if you want to, or just if you're good at factoring, do that, it's usually faster. So what times what gives you x squared? That would be x times x. Now, when there's no number in front of the x squared, like over here we had a number in front of the x squared, so we couldn't use this trick, but when you have something like this where there's no number in front of the x squared, you can use a trick to factor where the numbers that go here have to multiply to 48 and add to the middle term, negative 14. So we have to think, what are two numbers that multiply to positive 48, and when we add them, we get negative 14? Well, that would be negative 8 and negative 6, because negative 8 times negative 6 gives you 48. And negative 8 plus negative 6 gives you negative 14. So then that would be answer choice B. So let's go to number 21. The expression right here, you guys are funny in the comments. The expression right here is equivalent to, so we are going to now say that we have an x squared term, so there's no number in front, so we can use our little trick, where it's just going to be x times x gives us x squared, and we need to have two things that are going to multiply to negative 264y squared and add up to 13xy. So let's see, we are going to, let's see, what could do that? That would be, hold on, I think that's, let me try 20, I'm going to try 22 times 12, I think, stupid calculator, 22 times 12, that is 264. Yeah, I was right. It's the 22 and 12 one. So it can't be the H, J, or K, but it has to be a negative and a positive, which both of these are. So you have to determine which one is the correct one to have the negative, which one's the correct one to have the positive, so that when you add them up, you get 13. So that would have to have the positive being with the bigger number right here, the 22, for it to be positive 13. When you do 22 minus 12, you get positive 13. So it would be G right over there. So give me a second really quick, hold on, I have to check to make sure that I don't have any editing errors. Okay, we're good. Okay, so what grade is this for? This is for, what's it called? ACT math, which is not like specific to grade level, like you take it in high school, but like it covers a lot of stuff, not just like one specific grade level of math, if that makes sense. Oh wait, did I do it wrong? Sorry, did I multiply it wrong? Did I put, hold on. Am I going crazy? 22 minus, hold on. 22 times 12. Hold on. 22 times 12 does not equal 264. I literally put it in the calculator. What the hell? 22 times 12. Okay. Huh. That's weird. Okay. That is so weird. Times 12. Huh. Okay. Well, let's see. So let's see. Hold on. Sorry, guys. Give me 1 second. I was going too fast, probably. Hold on. 22. So that's x squared, because then you would get, because if you FOIL this out, you get x squared, and then it's going to be plus 22xy minus 12xy, and then, I swear to God, my calculator is saying 22 times 12 is 264. So then that would be negative 264 y squared, and then that would be positive, yeah. It's the xy term. I'm just not seeing it. 22 minus 12. Oh my gosh, I literally slept like 2 hours last night. I'm so sorry. Like, I can't believe I missed that. 22 minus 12 is not 13. Oh my God. Okay, sorry guys. Okay, so we have 24 times 11 is going to be 264. Okay, so, sorry, we'll redo this. 1 second. So, the x times x is going to be x squared. So then, I was like thinking, like, is my calculator broken or what? No, I was just like doing the mental math wrong in my head. Sorry. So, we have 24 times 11 does equal 264. So then it just has to make sure that, we just have to make sure that it adds to the positive 13. So it's going to be the positive 24 minus 11. And let me just write it down just to make sure I don't get it wrong. Yes, that does equal 13, so it's going to be J. Okay, so let's go to number 22. Sorry about that. Which of the following is equivalent to this one right here? So we're going to factor out the greatest common factor, B. So it's A minus B over here that we were left over with, and you could always check that to see if you factored it correctly by multiplying the A, or the B times the A and the B times the negative B. You would get back to that. And then we're going to take out the greatest common factor of A on the bottom, and then we have B minus A. Now, you can remember, I'm going to show you the logical reasoning behind this, but you can just remember that if you have like x minus y over y minus x, or like in this case, A minus B over y minus, A minus B over B minus A, that these cancel out to -1, like when they're flipped with the negative. But the logical reasoning behind that, I'm going to show you right now, is that if we were to factor out a -1, so this is B times, let's factor out a -1 here. And if we put a -1 out there, how are we going to get back to A? On the inside, we would have to multiply by -A. And then we would have to say, how are we going to get back to -B on the inside? Well, then this would have to be plus B. So this would be -A plus B if we factor out a -1 over A times B minus A. Now, remember, if we have a negative plus a positive number, that's the same thing as saying that positive number minus that value right here, A. This is the same thing as saying B minus A. So that's the logical reasoning behind why these cancel out to -1, but you can just remember, like, if they're flip-flopped like that, that it cancels out to -1 to make your life easier. So it would be -B over A. So then it would be A. So then let's go to number 23. It says simplify the following expression. So here, these are just fractions. Even though we have like a bunch of variables involved, it's still just two fractions being divided. So we have to keep, change, flip. So we're going to keep this value right here, this fraction, the same. We're going to change the division to multiplication, and we're going to flip this fraction to its reciprocal, so it's x on top and x minus 3 on the bottom. Now what I want to do is I want to factor the top and bottom over here to see if there's anything that I can cancel out. So we're going to say, okay, x squared minus x minus 6 could be x minus 3 times x plus 2. And then on the bottom, we could say, okay, I'm going to take out 3x as the greatest common factor, and then that's going to leave me with x for this portion, and it's going to leave me with plus 2 for this portion right here. And then I'm going to copy down the rest of my problem. This is for ACT math for people that are wondering. Hold on, let me just block somebody. So then what we're going to do now is we're going to cancel out the x plus 2 and x plus 2 on top and bottom right over here. And we could cross cancel the x minus 3 and the x minus 3 right here. And when I say cross cancel, these just turn into a 1, but I'm just not going to write that, but you can if you want to. And then we're just left with an x on top and a 3x on bottom. The x and the x can cancel out. So this just would be a 1 over 3, 1/3 k. So let's keep on going to number 24. Which of the following correctly rewrites the equation right here in terms of b? Remember, I've mentioned this before, the in terms of trick. This doesn't always work, but it works like I would say 9 times out of 10 for problems that say in terms of. And basically the trick is that you're just trying to get whatever's in front of it by itself. Because people usually, like, especially when they are really wordy and they add a bunch of like context before, like they give you like a basic, like a story problem before they ask you what to actually find. Whenever you see the words in terms of, you're just isolating the variable before it. So we're just trying to get a by itself because that's what's in front of in terms of. So to get a by itself, I'm going to first move the 32. Now, if you struggle with what do I move first and how do I move it, that sort of thing, like you don't know how to solve for x and you're always like moving the wrong thing first, what I teach my students that works most of the time to help them out, because again, there are exceptions, but is something called SADMAP. So SADMAP is the reverse of PEMDAS. Remember, algebra is just the reverse of like regular math that we're used to. We're going backwards to find out what x is. So it makes sense that the reverse of PEMDAS would be the steps that we should be moving things in for algebra. So SADMAP, again, PEMDAS in reverse, tells us what we're going to move, basically, in order. So this says we're going to move anything that's being subtracted or added to our variable, with a right here. So we have to move the 32 first. How do we move it? By doing the opposite operation between the variable and that thing we're moving. So there's addition here between that and the variable, so we have to do subtraction to move it. So we're going to cancel that out. So then it's b minus 32 is equal to 4a to the third power. Now SADMAP says next we're going to do any division or multiplication, move anything that's being divided or multiplied by our variable a. So we need to now divide by 4 on each side to move it to the other side. So if we divide by 4 on each side, this cancels out. And then over here, it would be b minus 32 over 4, because remember, a fraction bar is the same thing as a division sign. And that equals a cubed. And we can divide each of these terms by 4. So we could say that this is b over 4 minus 8. And that equals a cubed. Now, SADMAP, the e is for exponents, so you have to move the exponent away to get a by itself. It's also the only thing left to move, so you know that. So what we're going to do is the opposite of cubing, which is cube rooting each side to get the a by itself. So I'm going to cube root each side, which is also the same thing as raising something to the 1/3 power. So I'm going to show you the cube rooting way because a lot of people get confused if I just start raising it to the 1/3 power. And I'm going to show you how you can get there logically from this. So cube rooting is the opposite of cubing. So those cancel out and we just get a now. Now over here we have the cube root of b to the 4th minus 8. And the exponent is not negative, no. So now the reasoning behind this all being raised to the 1/3 is because whenever you have a radical like this, basically whenever you have this little symbol right here, whether it has like a 3 on the outside or it's just by itself, the way you could rewrite it as an exponent, as something within an exponent that's a fraction, is you could say, okay, all the stuff inside, what is it being raised to? This is all technically being raised to the first power. So we have b over 4 minus 8, all being raised to the first power, over, as my denominator, it's the type of radical I have. The type of radical is a cube root, so I put a 3 there, and that has to equal a. A simpler version of this, because people get confused when they see like the b and the 8 and all the other numbers, a simpler way to say this is, like, let's say that we had the cube root of x squared right here. That's equal to x to the 2 over 3, x to the 2/3. You just put the exponent of everything on the inside over the type of radical it is on the outside. It's just that rule, but just a little harder because you have more terms. So it's going to be answer choice B. Someone's asking, when am I going to go live again? So what is today? I can't even remember the day. Today is Monday, right? I think it's Monday. Yeah, so I will probably go live again this week at some point, just at a random time. I don't know. I'll try to announce it like under my profile picture because I can like announce live events now under there. But I'm definitely going live, like scheduled for Friday at 6 p.m. Eastern time. Will definitely be the next time. It's always Monday and Friday at 6 p.m. Eastern time for sure. And then I do like extra lives throughout the week as I feel like it. So yeah. So let's go to the next one, number 25. Thank you for the roses, guys, by the way. So let's go to number 25. What is it? Will you be wrong constantly like today? Oh my gosh. If you don't like it, you can leave. I don't care. Okay. Oh my god, how does this person keep getting in? All these like bots and stuff. Okay. So, let's go to number 25. So number 25 says, what is the sum of these? So sum, remember, is addition. So that means we're adding these. How did I get wrong 4 times? I got one thing wrong. Oh my goodness. I'm just getting rid of this person. I can't get them to go. Hold on. There it is. I think it worked that time. Okay, so we're going to do the sum. So we're going to add these up because sum means that we're finding the answer to addition problem. So 0.2 plus 0.3 x squared is going to be 0.5 x squared. And thank you for everyone being respectful and saying thank you. It means a lot. And then let's go to 5x minus 4x, which is just going to be plus x. And now we have to add up 64 and 28, and that's going to be 92. So then we have that would just be f right there. Let's see. Let's go to number 26. When are we going to use this in real life? I keep seeing that question pop up. Probably never, unless you're a tutor like me and make a career out of this. Then you'd use it in real life. But, I mean, I'm not here to tell you that you need this in your life and that it's super important. I'm just here to tell you that you need this for the SAT or ACT, whatever you're taking, to pass and get a good job. If, like, well, not necessarily to get a good job, because you can go to vocational school and trade schools and make a ton of money. Or, like, become an entrepreneur and stuff. But, like, if you want a specific job that's considered, like, a good job, like a doctor or whatever, you need, like, to get a specific type of education. So then let's go to the next one right here, 26. Which of the following is equivalent to the expression right here? So, yeah, and then also like job tests, someone brought that up. Yeah, a lot of jobs have like testing and like aptitude, but like I think they're talking about like in day-to-day life is what they're saying. So anyway, let's see which of these is equivalent. So let's do distributive property because we have something pressed up against parentheses. So we're going to distribute or multiply this times each of these. So it would be negative xy over x, because we just multiply those. And now we're going to multiply y over x times y. So it's going to be plus y squared over x. And then these are going to cancel out if we wanted it to, but I just realized as I did that that's not smart. Because, oh, actually, it is smart, because I thought that I wrote this book. I thought that I had written this as it was just going to all go over one thing, but I can just cancel it out because it's written as 2 separate things. So I'm going to just cancel that out, and that's going to be y, negative y, plus y squared over x. Hold on. Am I going crazy? Y, because I was like, it's flipped. That's why. Y squared over x minus y is the same thing, because if you add a negative, it's the same thing as subtracting by it. So then let's see, that's going to be, that's just f, yeah, right there. Okay, so let's go to, okay, people are something else. Okay, let's go to number 27. So which of the following expressions is equivalent to all of this? Yes, I wrote this book for people asking. Which of the following expressions is equivalent to all of this? So let's see. If you look at the answer choices, that's another thing that I should have mentioned before starting this chapter. One of the things that you can do as a strategy on test day is look at the answer choices to see what they might have done. like over here, you see, okay, they probably divided each of the top terms by whatever's on the bottom to get these answers. So that's what I'm going to do. I'm going to say I'm doing x squared over 3x minus 3 over 3x. So I can cancel out an x down here for an x up here. So then it's just x over 3 minus, and then the 3's cancel out, so there's just a 1 left on top, minus 1 over x. So that's going to be x over 3 minus 1 over x, which is e, right over here. So let's go to number 28. Let me get water really quick. Okay, so let's go to number 28. Which of the following is equivalent to the expression right over here? So we're going to do x plus 2 times x plus 2. And this is one that I've seen a lot of the times on the SAT exam and ACT exams, like that people will get wrong for like a silly reason because they forget that this is the same thing as this. So they just distribute the 2 or like do power to a power for the 2 when you can't do that when you have 2 terms in parentheses times 2 terms plus or minus in parentheses. This means you have to FOIL. So we're going to FOIL, which means we're going to multiply the first terms x times x, so that's x squared. O is outer, so we're multiplying the outer terms, x times 2, so that's plus 2x. I is inner, multiply 2x on the inside, so 2x. L is the last terms, 2 times 2, so that's going to be plus 4. And then we have to combine our like terms in the middle, so that would be plus 4x. And then we just copy down the rest. So that would be F. So why 2x? Because FOIL, that O stands for multiplying the outer terms, so we would have to do 2 times x. I stands for multiplying the inner terms, so 2 times x. So that's how we got 2x each time. So let's keep going. Chloe, stop. Number 29, which says, which of the following is the difference between this and this? So remember, difference means we're subtracting. So let me rewrite this over here. I'm going to rewrite the whole problem where it's just like right on top of each other. So 0.2x squared, Chloe, stop it, plus 5x plus 64 minus 0.3x squared. And then remember, this is minus. Sometimes I like to tell students so that they don't mess up that you put this whole thing in parentheses just so you know that you're going to minus each of the things and you're reminded of that before you copy down the whole thing. Because a lot of students will just like subtract the 0.3 and then for some reason they start adding the other stuff. So yeah, that's why I'm doing that. And then I'm going to copy down the rest and I'm going to say, okay, I'm subtracting each of these. So 0.2 minus 0.3 is going to be negative 0.1. So negative 0.1x squared. And then I have minus and minus is plus. So this is 5x plus 4x. So then that's going to be 9x. What is wrong with you? Hold on, let me finish this problem and then I'm going to let her out really quick. So then 64 minus 28, that's going to be, let's see, that's 36. Yeah, 36. So then it would be that is plus 9x, so that is D. Chloe got to use the bathroom. I don't know, maybe. She wasn't going out. She wouldn't go out before when I tried to take her. What are you crying about? Hold on, what is today's date? Maybe I can let her out. Hold on, give me 1 second to get Chloe all situated. Oops, why is this falling? Oh my gosh, okay. Chloe. Is Elvis out there? I'm just letting her out. She doesn't need to be quarantined anymore, the doctor said. Can I let her out? I'm just going to let her out. Okay. So, let's go to number 30. The expression right over here is equivalent to, so we have a fraction plus a fraction, so we're just going to have a common denominator. So we have to get a common denominator of 3x by multiplying this by x. Remember, if you multiply the bottom, you have to multiply the top by x as well. And then times 3 on the bottom and times 3 on the top over here. So what we're going to do is we're going to get 2x over 3x plus 27 over 3x. And just like when we're adding regular fractions, like just when you have like 1/4 plus 3/4, you just keep the common denominator, 3x, and you add the numbers in the numerator on top. So we should get 2x plus 27 over 3x, so that would be h for that one. So then let's go to, hold on, did I get distracted on this problem? Hold on. Minus, hold on. Difference between that, hold on. No, I think that's fine. Okay, sorry. I thought I saw something. So then let's go to number 31. So which of the following is equivalent to the expression right over here? So we have to FOIL this. Thank you guys for the roses. And if you want to support my channel, I just released a new TikTok series that's super helpful if you need to cram for the exam. It's like an hour and 15 minutes total, and it tells you like exactly how to prepare for test day and like the stuff you need to remember, like little tips and timing strategies, things like that. It goes over some of the formulas that you should recall and some tricks not to fall for on test day. And it's just $199, yeah. And so yeah, if you want to support my channel and get an awesome cramming guide, that's available for you. So we're going to FOIL, so that means we're going to multiply the first term, 6x times 3x, which is going to be 18x squared. And then the O stands for multiplying the outer term, so 6x times negative 2, so that's going to be negative 12x. And then I stands for multiplying the inner term, so 2 times 3x is going to be plus 6x. And then we have L for the last terms, 2 times negative 2 is going to be negative 4. So now we're going to combine our like terms right here of negative 12x plus 6x. That's going to give us negative 6x. And then we just copy down the rest, the minus 4 and the 18x squared. So then that would be A for that one. So then let's go to number 32. It says, which of the following expressions is equivalent to, sorry, I'm going to answer a question really quick. Can you do a live about solving equations with integers? I'm struggling. So I actually have a, if you go to my YouTube channel, it's the same name as this TikTok channel, AG Tutoring. If you go to, there's a series called a playlist on my playlist thing that says Overcoming SAT Math. If you go down like 3 or 4 videos on that playlist, there's something called 3 reviews. And in that, one of the 3 reviews is doing arithmetic with integers. So there's like a whole thing on that. So number 32, which of the following expressions is equivalent to all of this? Okay, so let me think really quick. This is going to be, okay, this is that formula that says x squared minus y squared is equal to x plus y times x minus y. So basically, if we think about x being equal to a minus 1 and y being the b plus 1, this is just x squared minus y squared. If we just replace x with a minus 1 and b and y with b plus 1. So if we want to replace the x on the other side of this formula with a plus 1 and the y with b plus 1, it's going to look like this. I'm basically just doing the right side of this and plugging in a minus 1 for x and b plus 1 for y. And then I do the same thing over here, a minus 1, and then it's minus b plus 1. So minus the whole thing of b plus 1. That's why I'm putting it in parentheses to remember to subtract the whole thing. So now I'm going to simplify this. So I'm going to say a plus b, and then the negative 1 and 1 cancel out. So it's just a plus b. And then over here, I'm going to say, okay, then minus has to go to each of these. So this is technically a minus 1 minus b minus 1. And then if I keep going, negative 1 minus 1 is just negative 2. So it's going to be a minus b minus 2. So then it would be G.